Hi everyone, Radek here from NetVault. I'm here to demonstrate our fibre with 4G failover service in a real-world production environment at one of our end users from one of our channel partners. So we're here inside the customer's comms rack, and over here you can see the customer's got an optical fibre termination unit, which is the fibre that comes in from the street into the customer's comms rack. From here, the fibre then feeds into a network termination unit, an NTU, and you can see there's the fibre that comes in to the NTU there. From there, the fibre is then fed into this Cisco router. Now this is one of our Cisco routers that has our unique 4G LTE failover solution. Now this particular router has traffic going across the FE4 fibre WAN interface, and here you can see the lights for the 4G LTE service. Internally within this router, we use technology, MPLS technology and BGP failover to achieve this failover that I'm about to demonstrate for you. From here, the Cisco router then feeds into this Sophos XG firewall, which then protects the rest of the internal network security. So what we're going to do is we're going to focus on this solution here and show you what actually happens when we do a 4G LTE failover test in a real world environment. So over here on my laptop, I'm going to log on to NetMon. NetMon is our monitoring and management interface that we've got that all of our clients and channel partners get access to. In here, we have this particular service, and over here we've got a nice little map of Australia showing where the service is, and you can see that's located here in Brisbane. As far as the information that's presented within NetMon, you can see that the ping times on this service is currently up. There's 15 millisecond latency to it, and we've got traffic flowing across the fibre internet service, about 1.3 megabits per second of traffic flowing through it as background traffic. And this particular customer has three interfaces. They've got a data VLAN, a DMZ VLAN, which goes through to the Sophos XG firewall, and their voice VLAN for their voice traffic, so that can be prioritized and optimized through the service. If I have a look at the 4G LTE statistics, we can see some information about the signal quality on this particular service. It's not that bad, it's not that great either, but a decent 4G failover service for the client. Traffic on the 4G LTE interface, you can see that's sitting there just about almost zero. Okay, we do send a bit of keep alive traffic through the route through the 4G LTE interface, but that's pretty much sitting at almost zero. All the traffic at the moment is currently going through this fibre primary interface. Over in this window, I've got some pings going to 8.8.8.8. This is Google's DNS servers, and you can see here we're getting around about 14-15 milliseconds pings to Google's constantly on that, with no packet loss. Okay, let's have a look at good old speedtest.net and see what sort of speed we get out of this internet connection. One of the things to note while we're doing that is the public static IP address that you can see down here. Now you'll note that during our speed testing and all our testing, this IP address will not change. That will stay the same. And you can see that as far as download speeds at the moment, this is a guaranteed 50 meg fibre internet service, business grade, so we get around about 45 to 50 megabits per second on the download, allowing for 10% protocol overheads. That's pretty much spot on. A nice 2 millisecond ping time on the latency. Uploads are a little bit slower with all the other network traffic that's happening, and most of that is probably actually going to be slowed down due to the Sophos XG firewall particularly deployed. Alright, great. What I'm going to do here is I'm going to kick off a download to a CentOS Linux ISO image. Okay, this is to simulate some more network traffic on the network for us. And you can see I'm getting about 2.5, 2.6 megabytes per second of traffic downloading that file. Okay, what I want to do now is show what happens when we go and unplug this fibre internet cable on our NTU and simulate a failure of this fibre circuit. The Cisco router is currently got the traffic, you can see flashing away there on the WAN side, The 4G LTE interface is sitting in standby, like an active standby sort of thing. If we then go and unplug the fibre cable, there's that cable unplugged. And you can see straight away our WAN light has gone off. Okay. BGP internally in the Cisco router has failed that over. If we go and have a look over here at our ping tests, you can see these ping tests have gone from a 14, 15 millisecond latency up to about a 50 to 60 millisecond latency, and we lost one ping packet here during that failover. This is the sub 1 second failover that we keep talking about with our internet service. We can fail over from the primary fibre over to the 4G LTE interface in under 1 second. This means that any voice calls, any downloads, any internet banking transactions, they will stay the same. If I just pause that and run this speed test again, notice this IP address that we've got. Notice that that IP address has not changed. This is how voice calls are able to continue uninterrupted. There's no re-initiation of SIP sessions, no SBC renegotiations, nothing like that has to happen. And you can see here our latency for our 4G LTE is about 30 milliseconds. It's to be expected. It is slower than a fibre circuit. Download speeds are around about 16 megabits per second with this particular setup. Uploads about 10 megabits per second. So while the service is slower than the primary fibre, it is a failover service, which we have failed over in under 1 second. If we have a look at NetMon and have a look what's happening here in NetMon, if I refresh the pages there, you'll see that we now have a red sensor here on the 4G LTE traffic. That was green before with almost no traffic. Now we've got 16 megabits per second of traffic on the 4G LTE interface. What about the primary fibre? If we go and have a look here at the FE4 primary fibre interface, you can see that is now showing 0 from a traffic perspective. All the traffic has now gone over to the 4G LTE interface while maintaining the same public static IP address. Now, let's go and plug that service back in and fail that back. So if I take the fibre cable, plug that back into our NTU, you'll see that pretty much straight away the FE4 light comes back on the router, but the router uses BGP and MPLS technology to achieve this. So it won't fail that over straight away. It'll check a few things and make sure that the service is ready to fail back. So the traffic is probably still over here on our 4G LTE, and this is going to be idle. Let's have a look at our ping that we've got going on. Yeah, if you just notice here, right here, we've changed from a 55 millisecond ping to a 14 millisecond ping. There's our fail back. That's the service going back from a 4G LTE backup failover interface back to the primary fibre with our 14 to 15 millisecond pings. If I go and refresh that, you'll see that traffic flow on these sensors updates every 60 seconds. And you can see we're starting to get traffic now flowing back through to the primary fibre. If I go back into the 4G LTE sensors, you can see that's starting to go back down to 0. So that's how we show a failover from a primary fibre to a 4G LTE interface utilising BGP technology and MPLS to achieve the failover in under 1 second. Now, just to prove there's no smoke and mirrors, what happens if we go and physically sever the fibre cable? Do not try this at home. If I take that fibre cable and very carefully go and sever this cable, there's that cable severed. Let's have a look what's happened over here. If we go back and have a look at our ping tests, notice the failover. We've gone from 14 milliseconds to 48 milliseconds. We've lost one ping packet during the failover. If I then go and refresh this again, you will see traffic now starting to go back onto the 4G LTE interface when the primary fibre is now going to be 0 here shortly. So there you have it. There we have a real-life working example of a business fibre as a primary with a 4G LTE failover as a secondary internet connection. These type of services are fantastic for those clients who need near 100% uptime on their internet connectivity, where they can fail over from the primary internet connection, being a fibre in this instance, to a 4G LTE connection in under 1 second, keeping the same public static IP address and no 4G data costs associated with the service. That's it from me, guys. If you need any more information, please contact us. Our website is www.netvault.net.au, or give us a call. One of our friendly sales members will be happy to answer any questions. Thanks very much, guys. Have a great day.